Hello, everyone. Welcome to today's lesson. We're going to be talking about similar figures of solids and what happens if we change just one dimension on one of our solids. So these notes are available on OMHS as well as their key. And let's start by first talking about similar solids. Okay, so we are going to say that solids are similar if they have the same shape, but not necessarily the same size. Two solids are going to be similar if the ratio of their corresponding linear measurements are equal. Their corresponding linear measurements are equal. And remember, in the past, we have called this a scale factor. And we talked about scale factor when we talked about similar figures, similar triangles, and we also mentioned it when we talked about a dilation, because when we took a dilation, we made our figure either bigger or smaller by a scale factor. They were the same shape, but not really the same size. Different types of linear measurements that you're going to hear or that you've heard already in this course are length, width, height. You can probably think of a few. Maybe slant height. A perimeter, that's a linear measurement. A radius or a diameter, or even a circumference. Anything that can be measured with a length, that is a linear measurement. Okay, so with that being said, we're going to be given two figures and we need to know, are they similar? If they're similar, then they're going to have a scale factor that will be the same for all of the linear measurements. So for example, here 12 is the height of this pyramid and 3 is the height of this pyramid. So as a ratio, that would be 12 over 3. Well, 8 is the width and 2 is the width. So the ratio would be 8 to 2. Or the length, 20 to 5. Well, 12 over 3 reduces to 4 over 1. 8 over 2 reduces to 4 over 1. And 20 over 5 reduces to 4 over 1. Those are all equal. So because all of those ratios reduce to the same number, we can say, yes, they are similar. And then the scale factor is whatever they reduced to. So our scale factor, you could write it as a fraction, 4 over 1, or you could write it with that colon. Remember doing that with our similar figures? So the scale factor can be 4 to 1. Looking at number 2, I want to know, are these figures similar? Okay, so 6 feet here corresponds to 10. This 6 feet corresponds to this 10. Clearly, those are equal. And then 8 corresponds to 12. Okay. Well, if I were to reduce the fraction, 6 over 10 really reduces to 3/5. And 8 over 12 reduces to 2/3. All right, these guys are equal, but these ones are not. So because 3/5 does not equal 2/3, we will say that these are not similar. Because they're not similar, there isn't going to be a scale factor. I want you to try number 3. I've got 2 cylinders in number 3. Write the ratios of their corresponding linear measurements and determine whether or not these two figures are indeed similar. If they are, tell me what the scale factor is. So you should have said, yes, they were similar because 12 over 10 and 30 over 25 reduced to the same fraction, 6 over 5. If you didn't do 12 over 10, maybe instead you said 24 over 20, and it still reduces to 6 over 5. So that's okay. So now we can talk about comparing volume and surface area. If two solids are similar with a scale factor of, and I'm going to call that scale factor A to B, and you might see it written as a fraction A over B, same thing, then their volume and the surface area ratios are going to be A squared to B squared, or you might see it written as a fraction A squared over B squared. And the volume, A cubed to B cubed, or, written A cubed over B cubed, same thing. So what we're going to do is we're going to look at our two figures, and we are going to be able to determine scale factor, surface area ratio, or volume ratio. And then once we can determine one of those, we can use that to determine the other two. So for example, first it already tells us they're similar. And if we weren't sure if they were similar, we could check that. 6/3 reduces to 2, 10/5 reduces to 2, 14/7 reduces to 2. So what is our scale factor? Well, it's 2, or 2 to 1, right? So I like to write that as A over B. You could say 6/3. You could have said 10/5 or 14/7. No matter which one you picked, it reduces to 2/1. So our scale factor is 2 to 1. Or if you wanted to write it as a fraction, that would be okay too. Then surface area. Your surface area is not A over B, but it's A squared over B squared. And I remember that because I remember the units for area are squared. So that means my ratio is also going to be squared. Okay, well, if A is 6, then A squared is 36. But you know, this 6/3 was reduced to 2/1. So instead of using the 6, I'm going to say that A equals 2. Okay, so if our scale factor is 2/1, that's our A over B. A is 2. So A squared is 2 squared. B is 1. So B squared is 1 squared. Well, 2 squared is 4 and 1 squared is 1. So the surface area ratio is 4 to 1. Or if you wanted to write it as a fraction, 4/1. Now your volume ratio is A cubed over B cubed. And I remember that because the units for volume are cubed. So the volume ratio is also going to be cubed. Right? So if A was 2, that means A cubed is 2 cubed. And if B is 1, then B cubed is 1 cubed. Remember, a cube is not being multiplied by 3. A cube is when you multiply that number by itself 3 times. So 2 cubed is 2 times 2 times 2, 8. And 1 cubed is 1 times 1 times 1, 1. So your volume ratio is 8 to 1, or as a fraction, 8/1. Okay. Knowing that, and knowing that these two codes are similar, come up with the scale factor, the surface area ratio, and your volume ratio. And if you need to go back and look at the previous example, you're welcome to do that. Go ahead and try this one now. All right. So we have two cones here. We know that the radius is 4 here, and the radius here is 6. I chose those numbers because they were whole numbers. I mean, you could have done the 7 and the 10.5, and it would have reduced to the same fraction. So your scale factor is A over B, which is 2/3. There it is, right? Because 4/6 reduces to 2/3. So now A is 2 and B is 3. So for your surface area ratio, you're going to square your A and square the B. B was 3. So you get 4/9. For your volume ratio, that's A cubed over B cubed. Well, A was 2 and B was 3. So 2 cubed is 8 and 3 cubed is 27. So far we've been calling this the scale factor. This is also known as the ratio of the perimeter, or the perimeter ratio. So if you hear someone ask you for the perimeter ratio, that's the same thing as the scale factor. That's just good to know in case you come across a problem like that. Now, what happens if they don't give you the scale factor, but they give you either the surface area or the volume first? Well, you can still use that information to find the other two. So for example, in number 6, they tell us the surface area. So since they tell us the surface area, they're giving us A squared over B squared, 25 and 4. You always want to reduce that fraction first. Always check to make sure, does this fraction reduce? If it does, reduce it. If it doesn't, leave it the way it is. 25/4 does not reduce. But now that I know A squared over B squared, I can find A over B. How would I undo this square? Well, I would square root. So if A squared equals 25, and when I square root both sides, A is 5. And if B squared equals 4, then I could square root both sides, and B would be 2. So now I know A over B. Oops, 5 to 2, not 2 to 5. Okay, so we have 5 to 2. They told us the surface area ratio, so I can just go ahead and write that in there. And now I need to find the volume ratio. Well, the volume ratio is A cubed over B cubed. A is 5, so that's 5 cubed. B is 2, 2 cubed. 5 cubed is 125. And 2 cubed, of course, is 8. So our volume ratio is 125 to 8. So if they give you the surface area, you then have to use that to find the ratio of your perimeter or your scale factor, and then use that to find your ratio volume. Your area and your volume can't talk to each other. You can't go right from area to volume. If they give you area, you have to find your scale factor and use that to find your ratio volume. Same goes the other way. Here in number 7, they give us the volume. So that's your A cubed over B cubed. That cannot talk to your surface area. You're first going to use that to find your A over B, and then use your A over B to find your A squared over B squared. So if you are not given the scale factor, whatever information you are given, use that to find your scale factor, and then use your scale factor to find your other piece of missing information. Okay, now again, like I said, it's always a really good idea to simplify this fraction if it can simplify. So we're going to simplify 162 over 384. That simplifies to 27 over 64. Okay. Now I need that to find A over B. To undo a square, we square root. We've been doing that all year long. How would we undo a cube? So if A cubed is 27, do you remember back in Algebra 1 you learned about cubes and cube roots? Well, a square root undoes a square. A cube root undoes a cube. So it looks like the square root, but it has a little 3 out front here. So let's practice finding the cube root in our Desmos calculator. All right, on the screen, you can see my graphing testing calculator. This is what the calculator will look like on your SOL. If I want to find the cube root, this button down here is not going to be helpful because this is a square root. I don't want a square root. I want a cube root. So what you're going to do is go into your functions tab, and the cube root is kind of hidden in your functions. You see trig, that's where we had our sine, cosine, tangent. And then there's 3 other tabs here that we haven't really explored too much. There's our stats, our distribution, and then miscellaneous. And miscellaneous is where you'll find your cube root. You see your little, it looks like a square root symbol with an N. You're going to choose that button, and it says, well, what kind of root do you want? Clearly, you don't want a square root, or else you would have used a square root button. So we want a cube root. So we type a little 3 there for cube root, and we want the cube root of 27. The cube root of 27 is 3. What that means is I can take 3 times 3 times 3 and get 27, and that's true. So the cube root of 27 is 3. While I have the calculator up, we are also going to be finding the cube root of 64. So functions, miscellaneous, nth root. I want the cube root of 64. 4. Okay, so back to our notes. We have the cube root of 27. The cube root of 27 was 3. Oops. And the cube root of 64, because b cubed was 64, and to undo a cube, we cube root. So the cube root of 64 was 4. So our scale factor is 3 to 4. Now I know the scale factor, or I know a over b, I can find a squared over b squared. Well, if a is 3, then a squared is 3 squared, and b is 4, so b squared is 4 squared. 3 squared is 9, and 4 squared is 16. So the surface area ratio is 9 to 16. The volume ratio, we're going to use the simplified version, 27 to 64. Okay, so something that we haven't really seen since Algebra 1 is how to undo a cube. How do you undo a cube? Well, you use a cube root. How do you undo a square? You use a square root. Hopefully that makes sense. I'd like you to try number 8. They give you the surface area. You're going to have to find the scale factor and then find the volume ratio. And I know this looks kind of weird here. This is 375. Looks like when this got screenshot, the cursor was right there. This is 375 right here. So go ahead and try number 8. Do that one now. All right, so when they gave us surface area, they were giving us a squared over b squared. So I said a squared over b squared was that 960 over 375. Simplify that fraction, it simplifies to 64 over 25. So your surface area can't talk to your volume. You cannot use the 64 over 25 and go straight to your volume. First, you need to find your scale factor. And then once you know your scale factor, you'll be able to cube those numbers to find your volume. So if I have 64 over 25 as a squared over b squared, how would I undo a square? Square root. So the square root of 64 is 8. And the square root of 25 is 5. So now I know my scale factor is 8 over 5. A is 8, B is 5. So to find my volume ratio, I need to take that A and cube it, B and cube it. And you get 512 to 125. Make sure you know how to cube a number on your calculator. If you need help with that, let me know. Let's look at number 9. Okay, now there's no picture here, but it's described pretty well. Some solid. I don't even know what it is. Maybe it's a cylinder, maybe it's a pyramid, who knows? Whatever it is, it's similar to solid B, meaning they're the same shape, they're just different sizes. The ratio of the height. Okay, height is a linear measurement. So if they're giving me the ratio of a linear measurement, they're giving me A over B. Solid A to the height of solid B is 7 to 3. So that's 7 to 3. Find the ratio of the volume. The ratio of the volume is A cubed over B cubed. Oh, well, A over B is allowed to talk to A cubed over B cubed. I can go straight from the scale factor to the ratio of the volume. A is 7, so A cubed is 7 cubed. B is 3, so B cubed is 3 cubed. So 7 cubed. I'll show you how to do that in the calculator, just in case. All right, so if you wanted to do 7 cubed, you would type 7. And then down here on your keyboard, you've got options, right? You have squares. That one's given to you already. But then you have this A to the B power. You're going to click that, and that'll make your exponent whatever you want. And I want 7 cubed, so I type a 3. So 7 cubed is 343. And while I'm here, let's cube that 3. 3 to the 3rd power. So I use that A to B button. The exponent is a 3, 27. So here we go. So 7 cubed is, what did I just say? 343. Whoops, did that again. And 3 cubed is 27. So your final answer, the volume ratio from solid A to solid B, is 343 to 27. There's your answer. Number 10 says that you have cones. Honestly, it doesn't matter what shape they are, as long as they're similar. And it says that cone A is similar to cone B. Great. The ratio of the surface area. Okay, so ratio of a surface area is A squared over B squared. From cone A to cone B is 16 to 1. Find the ratio of the radius. Radius is a linear measurement, so that means we're looking for A over B. Okay, well, if A squared is 16, then A, how would I get A? Like square root. How do you get rid of a square? Square root. So the square root of 16 is 4. And the square root of 1 is 1. So the ratio of the radii is 4 to 1. One thing that you really have to be careful about, because they will sometimes try to be tricky, is they'll switch up these letters on you, A and B, and they'll say like the ratio of the radius of B to A. So just be very careful. Make sure it's always going from A to B. If it switches on you, you have to switch your letters in your ratio. And we'll see an example where they do that to us. Yeah, that's coming. Okay, and these they aren't though. They're telling us, you know, we have cylinder A and cylinder B. They tell us about the diameter. It's a diameter 24 feet, and cylinder B has a diameter of 30 feet. What is the ratio of the volume? Go ahead and try number 11. And then in number 12, they're telling us what the volumes are of those two pyramids, and we want to know the ratio of the surface area. So go ahead and try number 11 and try number 12, and then we'll go over them together. So try those now. All right, for number 11, you should have gotten 64 to 125. So they give you the diameter of cylinder A and the diameter of cylinder B. Diameter is a linear length, so that's your ratio of A to B. Well, 24 over 30 can be reduced, and it reduces to 4/5. So now that I know the 4 over 5 is the scale factor, I can find the ratio of the volume. Volume is A cubed over B cubed. Well, A was 4 and B was 5. So A cubed over B cubed is 4 cubed over 5 cubed, 64 over 125. Number 12 is a little trickier because they gave us the volume and they wanted to know the ratio of the surface area. But I can't go from volume to surface area. I have to go from volume to scale factor and then scale factor to surface area. So I write down the ratio of the volume that they gave us, 648 to 1029. Always reduce that fraction if you can. Okay, so that reduces to 316 over 343. I need A over B. I need to know the scale factor. How do I undo a cube? Cube root. So I find the cube root of 316, that's 6, and the cube root of, what's 216, that's silly. 216, and then the cube root of 343, that's 7. So now A over B is 6 over 7. Right, well now that A over B is 6 over 7, I can find the ratio of the surface area. Surface area is A squared over B squared. A is 6 and B is 7. Square each of those. Your final answer is 36 to 49. Okay, so if they give you a volume and they're asking you for surface area, you first have to find your scale factor. If they give you a surface area and they ask you for volume, you have to find the scale factor. If you don't know the scale factor, A over B, then you need to find that in order to find the other piece of information. Okay, so one more time. We've got 3 different ratios. We've got our scale factor, A to B, our surface area, A squared to B squared, and our volume, A cubed to B cubed. Always reduce your ratio. Always check, can this fraction reduce? If it doesn't reduce, then that's fine. But if it does reduce, you want to use the reduced version. And then just like I said, if you're given the surface area or you're given the volume, you have to find your scale factor first. All right, so in number 1, it says the cones are similar. What is the ratio of the surface area of the larger cone to the smaller cone? Okay, so that means this will be my A cone and this will be my B cone. So they give us a slant height. Slant height represents a linear measurement. So I'm looking at my A over B, 28 over 8. Reduce the fraction. Always, always reduce that fraction. 7 over 2. Now it wants to know what is the ratio of the surface area. So that's A squared over B squared. So now that I know A is 7 and B is 2, A squared over B squared is 7 squared over 2 squared. So our final answer, the ratio of the surface areas is 49 to 4. So what does this mean, really? What this means is that for every 7 yards on this cone, for every 7 yards here, there were 2 yards here. And for the surface area, for every 49 square yards, so for every 49 square yards, there are 4 square yards on the smaller one. Okay. Try number 2. Number 2, they tell you the length of the base of each pyramid. They're similar pyramids. What would be the ratio of the volume of the smaller pyramid to the larger pyramid, meaning your smaller pyramid number will be on the top of your fraction. The larger pyramid number will be in the bottom of your fraction. Go ahead and try number 2 now. All right, hopefully you got 27 to 64. Okay, if the length of the first pyramid is 16.5, and then the length of the larger pyramid is 22, we say, okay, well, the smaller pyramid to the larger pyramid is 16.5 to 22. Simplify your fraction. 16.5 over 22 reduces to 3/4. So now A is 3 and B is 4. So the ratio of your volume is A cubed over B cubed. And there it is. So for every 27 cubic meters in your first pyramid, there are 64 cubic meters in the larger pyramid. Okay. In numbers 3, 4, and 5, they are going to give us either the surface area or the volume, and we need to use that to find some other piece of information. So in number 3, the cylinders are similar. What is the ratio of the radius of the larger cylinder to the smaller cylinder? So that means I start with my larger cylinder, so this is A, and go to my smaller cylinder, B. They give me surface area, so they're giving me A squared over B squared. The surface area of the larger one is 1/16, and the surface area of the smaller one is 29. Reduce that fraction. So you can do that in Desmos or your calculator. That reduces to 4/1. Most of the time, especially for this course and this does so well, these should reduce to, perfect squares or perfect cubes if you're dealing with volume. And the question is, what is the radius of the larger cylinder to the radius of the smaller cylinder? Okay, a radius is a linear measurement. So that means I'm looking just for A over B. Okay, A squared is 4, so that means A is 2, take the square root. B squared is 1, so B is 1. And if you need to do that step by step, you can. A squared equals 4, take the square root. There it is. B squared equals 1, take the square root. There it is. So the ratio of your radii is 2:1. So for every 2 millimeters, every 2 millimeters on this radius, there's 1 millimeter on this radius. Number 4, we have 2 prisms. If the prisms below are similar, what is the ratio of the height? Okay, that is a linear measurement. They give us the volume. Volume is A cubed over B cubed. And it wants the smaller prism to the larger prism. Smaller to larger, A to B. So A cubed is 15 and B cubed is 405. Reduce that fraction, 15 over 405 is 1/27. And they want to know about the ratio of the heights. Height is a linear measurement, that's A over B. So how do I go from A cubed to an A? Cube root. The cube root of 1 is just 1. B cubed is 27, so take the cube root of both sides, and you get 3. So the ratio of their heights is 1:3. For every 1 centimeter of height here, there are 3 centimeters of height over here. And then number 5 is one where they give us the surface area and they're asking us for volume. So again, surface area can't talk to volume. So we're going to take that surface area ratio, find our scale factor, and use the scale factor to find the volume. So surface area, A squared over B squared. It's a smaller pyramid to larger pyramid. So this is pyramid A, pyramid B. Surface area is 52 to 325. Reduce your fraction, 4/25. My final answer, I want an A cubed over B cubed. But I can't go from a square to a cube. First, we need to find our scale factor. So if A squared is 4, that means that A is 2. If B squared is 25, then B is 5. And I find that just by taking the square root. Now A is 2 and B is 5. So A cubed is 2 cubed and B cubed is 5 cubed. 8 over 125. So the ratio of your volume is 8 to 125. There it is. And then number 6, we have 2 prisms, and they want to know the ratio of the surface area given the volumes. So if they give us the volumes, they're giving us a cubed over b cubed. Let's see. Oh, this is the one where they switched it. I knew that was coming. What is the ratio of the surface area of the larger prism to the smaller prism? So just watch out. This is A, this is B. Okay. Anytime that they tell you the word 2 there, that 2 is actually super key because it tells you what goes on top, what goes on bottom. So this is 1458 over 128. Reduce your fraction. Most of the time it will reduce. 729 over 64. We want to know surface area. Well, volume and surface area don't talk to each other. So volume has to talk to scale factor, and then scale factor will talk to surface area. Okay, a cubed is 729. So how do you undo a cube? Cube root. So in your calculator, find the cube root of 729. You should get 9. B cubed is 64. So in your calculator, take the cube root of 64. And the cube root of 64 is 4. So now you know A and B. So now you can find A squared. A is 9, so A squared is 9 squared. B is 4, so 4 squared. So the ratio of your surface areas is 81 to 16. All right, now the next ones are a little different because what's going to happen is they're going to give you some information. You're going to have to find a missing surface area, a missing volume, a missing linear length, just depending on the problem. So in number 7, it says the ratio of the diameters of 2 similar cylinders is 3 to 5. Diameter is linear, so your A over B is 3 to 5. If the surface area of the smaller cylinder is 378, all right, surface area, A squared over B squared. The surface area of the smaller cylinder, so you look at your A over B, which one's smaller, 3 or 5? Oh, clearly 3. So this went small cylinder to big cylinder. So if the surface area of a small cylinder is 378, that's your A squared. Find the surface area of the larger cylinder. We don't know this surface area. Okay, so now we have to figure out, well, what is that larger surface area? Well, I know that the scale factor is 3 over 5. So I can figure out A squared over B squared. A is 3, 3 squared is 9. B is 5, 5 squared is 25. Look, I have an A squared over B squared and an A squared over B squared. They're the same thing, which means that what they're equal to has to be the same thing. This is our transitive property from way back in what, unit 2? When you have what something is equal and they're equal to the same thing, it means these guys are going to be equal. All right, and now we're going to do something that we've all become really good at, I think, I hope, and that's cross multiply. We're just solving for x now. X times 9, 25 times 378, 9,450. Divide both sides by 9, 1050. All right, so the area of the larger cylinder is 1,050, and your units, the surface area, is square inches. So to set up our proportion, we had to use A squared to B squared. Let's do another one. The ratio of the surface areas, A squared over B squared, of 2 similar pyramids is 16 to 9. If the volume of the smaller pyramid, volume, so we're going to be looking at A cubed over B cubed. The volume of the smaller one, right? Well, where is that 297 going to go? Is it going to go in the top or the bottom? This is the smaller pyramid. So I'm looking here, which one of these numbers, 16 or 9, would represent the smaller pyramid? Clearly it'd be the 9, because 9 is smaller than 16. So the smaller pyramid volume will go in the bottom. Find the volume of the larger pyramid. I don't know it, I'm going to call it X. Okay, so just like I've been saying, surface area and volume can't talk to each other. So the 16 over 9 is not going to help me with the X over 297. But what I am going to find is my A over B. Okay, well, if A squared is 16, that means A is 4. B squared is 9, so B is 3. Now I can use that A over B to find A cubed over B cubed. Well, A is 4, so 4 cubed is 64. B is 3. 3 cubed is 27. So I used all of that, and now I have an A cubed over B cubed, A cubed over B cubed. They're the same thing, which means these have to be equal. So I can say 64 over 27 equals X over 297, and cross multiply. You get some big numbers. 64 times 297, 19,008. Divide both sides by 27, 704. So that X represents the volume of our larger, larger pyramid. It's a volume, so your units are going to be units cubed. So for this one, we needed to use A cubed to B cubed to set up that proportion. Okay, so our answer is 704. If you're not sure if you put that 297 in the right place, look at your final answer. We just said that the 704 centimeters cubed was the volume of the larger one. That had better be larger than the volume that they gave us, and it is. If you would put that 297 in the top, then you would have gotten a much smaller number here, smaller than 297, and that should have thrown you off a little bit, right? Make sure that the larger cylinder is actually larger, or the smaller cylinder is smaller. Go ahead and try number 9 and try number 10. Be very careful where you put the given information. Try number 9, try number 10. Do that now. All right, so for number 9, you should have gotten X is 10. They tell you the volumes, 840 to 105. Reduce your fraction. X is a linear measurement, so you just need A over B. Well, if A cubed is 3, or A cubed is 8, then you take the cube root of 8 and you get 2. And the cube root of 1 is 1. Okay, so the scale factor is 2 to 1. This length was 20 and this length was X. So 2 to 1 or 20 to X. They are both A to B. So since this is A over B and this is A over B, I can say that they are equal. And I cross multiply and you should get 10 centimeters. For number 10, we have cone A and cone B. The surface area of cone A is 108 and for cone B is 147. Reduce your fraction, you get 36 over 49. Then they start talking about volume. So volume is an A cubed over B cubed. And it says the volume of cone B was in the bottom, is 857.5. And we need to find the volume of cone A. So I called that X. Surface area, volume won't talk to each other. So I'm going to use the surface area to find my scale factor. A squared is 36. Square root, A is 6. B squared is 49. Square root, B is 7. Now I know the scale factor, 6 over 7, and I can use that to find A cubed over B cubed. If A is 6, 6 cubed is 216. B is 7, so 7 cubed is 343. So here I have an A cubed over B cubed and an A cubed over B cubed over here. They are both A cubed over B cubed, which means they are equal. Cross multiply, divide by 343, and that's where the 540 came from. Now this was a volume, so the units are millimeters cubed. All right, so that's what happens when you have similar figures. What happens if we have a solid, but we multiply it by a scale factor? And we're going to call that scale factor, we'll call it A. Okay, and you could call it like a over 1 if you wanted. Okay. What's going to happen though is if I take this solid and I multiply its dimensions by a number, then its surface area is going to be that number squared times bigger, and its volume will be that number cubed times bigger. Okay, so let me show you. In number 1, the dimensions of a figure are doubled. Okay, so if the dimensions are doubled, let's pretend it was like some rectangular prism or something. Wow, I can't draw a rectangular prism, but there it is. If I double the length, I double the height. Whoa, try that again. I double the length, I double the height, I double the width. If that happens, then its surface area is going to be 2 squared as big. So it's going to be 4 times as big. And if you want to test that, go ahead and give it some numbers. Right? Give it some numbers, say like 3, 7, and 9, and then find the surface area, then double it and find that surface area. You're going to find that it really is 4 times larger. In number 2, the surface area of a figure is 62. If the dimensions are multiplied by 5, what will be the surface area of the new figure? Okay, so if we're multiplying it by 5, that means the surface area is going to be 5 squared as big, 25. So you're going to take that 62 and multiply it by however much bigger it is. It's going to be 25 times as big. So the new surface area would be 1,550. And of course, it's a surface area, so it's centimeters squared. Okay, so how much times bigger? Well, 5 squared times bigger. Times, you know that word times, it means multiply. So 5 squared times bigger, or 62 multiplied by 25. In number 3, we have a surface area of a figure. Originally, it starts at 736. The dimensions are multiplied by a 4th. What will be the new surface area? The surface area, you're going to take that whatever you're multiplying the dimensions by and square it. Okay, and that is what you will multiply by the original surface area. So if you have this figure and you multiply each side by a 4th, or you make each side a 4th as big, the new surface area will be 1/16 of that, or 46. It's a surface area, so it's inches squared. And then the last one, we have 2 cones that are similar, cone A and cone B. Cone A has a surface area of 1,422, and cone B has a surface area of 1,058. How many times larger is cone A than cone B? Okay, well, I can say, oh, well, 1,422 over 158 is 9. Okay, so that's 9 over 1, really, right? And if I wanted to know how many times larger is cone A than cone B, well, it's not 9 times larger. That was the surface area. So how would I find just A? What did I multiply the lengths by? Well, A squared is 9. So take the square root of both of those, 3. I multiplied it by 3. It's 3 times larger. Okay, the same thing works for volume. If I have the dimensions of a figure and I multiply it by 4, what's going to happen to the volume? So I have some figure here. Here it is, a cylinder, as best I can draw it. And I multiply the dimensions by 4. So now instead of this radius, the radius is 4 times as big. And instead of this height, the height is 4 times as big. What's going to happen to its volume? You're going to take whatever you multiply the dimensions by and cube it. So now it's going to be 64 times bigger. And that I'm talking about the volume. If the volume of a figure is originally 110.5 feet cubed and the new dimensions are doubled, what will be the volume of a new figure? Remember, double means times 2. So if the new dimensions are multiplied by 2, what will be the new figure? I multiply each of the dimensions by 2, and we're talking about volume, so I'm going to cube that. So that's 8. So if we start originally with 110.5 feet cubed, but then I change the dimensions, then that volume will be 8 times as big. So the new volume is 884 feet cubed. All right, let's see. At number 7, the volume of a figure starts at 972, and then the dimensions are multiplied by 2/3. So we need to know what's going to be the new volume. Okay, well, that means we're going to take that number that we're multiplying it by, and we're dealing with volume, so we cube it. So that becomes 8/27. So take the original volume and figure out, well, what happens when I multiply it by that a cubed, or that 8/27. So the volume after multiplying the dimensions by 2/3 is 288, and the units are meters cubed. All right, now I have two solids. They don't tell me what shape they are, but they're solid, solid A and solid B. The volume of solid A is 21, and the volume of solid B is 4,536. This is volume. So let's see. I wrote that wrong. I could do it this way. I'm going to do it the other way. I'm going to say B to A, just because that's easier to divide. 4,536 over 21 is 216. Okay, so that's how many times 21 goes into 4,536. But we want to know, that's the change in the volume. What's gonna, how many times am I multiplying the dimensions by? So if this is what A cubed was, that's what I multiplied by, and take the cube root of both sides now. So the cube root of 216 is 6. So we multiplied all of those dimensions by 6, but really it was 6 times smaller. Right, because we went from solid A is similar to solid B, but the volume of solid A is 21. The volume of solid B was 4,536. How many times smaller is solid A to solid B? You could also say that solid B is 6 times bigger than solid A, if you wanted to word it that way. Okay, and then the last thing, what happens if we change just one of the dimensions? There's not a trick to this one. Like we just said, that tricks were, oh, if I multiply the dimensions by 2, then the area is 2 squared times as big. If I multiply the dimensions by 4, then the volume is 4 cubed times as big. There's really not a trick to this one, because your figures aren't going to be similar. Okay, changing one dimension is going to make your figures no longer similar. So a different strategy is you're going to choose what we call test values. Then you're going to actually calculate the old and the new surface area or volume, and then you're going to compare your answers. When you choose test values, choose numbers that are really easy to multiply by or divide by. So you're going to see me choose the number 1 a lot as a test value. So for example, in number 9, how many times larger is the volume of a cylinder if the height is doubled? Okay, so what that means is you have a cylinder, and forgive me, my cylinder is not perfect, but I'm going to double the height, which means the radius isn't changing. The radius is staying the same. The only thing that's changing is its height. Okay, so we're going to pick some test values. So let's let this original shape have a radius and a height. I'm going to have to double the height. What number is really easy to multiply by? How about 1? 1 is super easy to multiply by. So I'm going to make the radius 1 and the height 1. So the volume of the small one is, right, you look at your formula sheet, the volume of a cylinder is pi r squared h. So for your first one, it's pi times 1 squared times 1. See why I picked 1? Because it's really easy to multiply by. So the volume of this is just pi. Then you have a new cylinder. The height is doubled. So if the height of the first cylinder was 1, the height of your new cylinder is 2. The radius didn't change. So the volume of your new cylinder is pi times r squared times h, 2 pi. Okay, so the volume of this guy is 2 pi. So now you have to compare your old volume to your new volume. How do you go from your old volume to your new volume? Oh, you multiply by 2. So how many times larger is the volume? The volume is 2 times larger. Number 10, you have a square pyramid. And you can draw a picture if you want to. Ooh, maybe better than mine. Try again. Okay, you have a square pyramid. And you're going to triple the base edge. So the base is going to get 3 times as big. The height is not going to change though. Pretend that's a pyramid. Wow. Okay. The height is not changing. The slant height is not changing. The only thing that's changing is this length is being tripled. So for the volume of a pyramid, the formula for that is 1/3 area of the base times the height. Okay. This is a square. So the area of your base is going to be side squared. So let's pick a length here. How about 1? If I let this length be 1 and the height be 1, okay, so the area of this base is going to be 1 times 1, and the height is going to be 1. So the volume of the original pyramid is 1/3 times 1 times 1. Okay, that's 1/3. Now, if I take that length and I triple it, like it says, what happens when it's tripled? Now the square is 3 by 3. So your base is now 9. The height's not changing. The only thing that changed was the base edge. So now we have a volume that is 1/3 times 9 times 1. 1/3 times 9 is 3, times 1 is 3. So how do you go from a 1/3 to a 3? Multiply it by 9. So the volume is 9 times bigger, or 9 times larger, however you want to word it. Okay. Try number 11 and try number 12. If you need to sketch a picture, that's fine. But what's going to happen to the sphere if your radius is multiplied by 1/2? What's going to happen to the surface area of a cube if the side length is multiplied by 1/4? Go ahead and try those two now. All right, so for number 11, you should have that sphere was 4 times smaller. So the surface area for a sphere is 4 pi r squared. If you let your original sphere be the radius have 2, then you can say that the radius of your new sphere is 1. If you picked different numbers, you're still going to get the same final answer. So I let the radius be 2, so that way when I multiplied it by 1/2, I got a radius of 1. You could have picked original radius of 4 and multiply by 2 and get a new radius of 2. Whatever you pick these test values at isn't really going to change anything. You pick your original radius and then you multiply it by 1/2 to get your new radius. And I just like the 1. So if my original radius was 2, then 4 pi times 2 squared was 16 pi. If I multiply that radius by 1/2, now my new radius is 1. So now this new surface area is 4 pi. How do you go from a 16 pi to a 4 pi? Yes, you divide by 4, but I'm not asking you what do you divide it by. I'm asking you how many times smaller it is. So instead of saying divide by 4, change your thinking ever so slightly to make it multiplying by 1/4. Okay, so 16 pi times 1/4 is 4. It is 4 times smaller, or it's 1/4 as big. 2 ways to word it, they mean the same thing. You can say it's 4 times smaller or 1/4 as big. Same thing. Number 12, we're talking about a cube. Okay, so the surface area of a cube is 6 times the side squared. And if you didn't know that, think about your surface areas of a cube. A cube is 4 squares. The area of a square is side squared, and there's 6 of them. I wanted to multiply each side by 1/4, and I know that 1/4 of 4 is 1. So I let my original side be 4. So that way when I multiplied it by 1/4, I got a nice pretty 1. So if the side is 4, then the surface area of that cube is 96. And then when I multiply that side by a fourth, my new cube has a side length of 1 and its surface area is just 6. To go from a 96 to a 6, I multiply by a 16th. So it's 16 times smaller, or it's 1/16 times as big. Okay. There's one more example there for you. You are welcome to try it. Oops. And that's talking about the volume of a cone. I'm going to let you just try that one on your own. You're welcome to check the key on OMHS for it. Okay, that brings us to the end of our lesson. That brings us to the end of our unit. This was the end of Unit 11. This was the end of the geometry curriculum. What? Yep, that's the end. So there will be a review available for you. And of course, the test will be open to you. Remember, the end date for everything in quarter 4 is May 13th. It will be available in office hours on Tuesday at noon. If you need any help, I am happy to help. Don't forget to do your exit ticket. Don't forget to do your attendance quiz. Have a great day, everyone.